Hi students, today we're going to be graphing some log functions. We're going to treat these as inverses of exponentials, so the way that we're going to think about them is if we are graphing exponentials and then graphing them in inverse. Alright, so that's what this is kind of leading us up to. So drawing the graph of 2 to the x, I'm going to identify some of these points in blue, so that's 0, 1, 1, 2, 2, 4, 3, 8, 1, a half, sorry, negative 1, a half, and it's going to look something like this. I've got an asymptote, that's my x-axis. And then we're going to think about the inverse of this. Remember that for inverse functions, we're switching our x and our y so that the point 0, 1 becomes 1, 0. The point 1, 2 becomes 2, 1. The point point 2, 4 becomes 4, 2. 3, 8 is going to become 8, 3. And then the negative side, the only point I really did was a half. So negative 1, a half is going to become a half, negative 1. And then instead of y equals 0 for an asymptote, we are going to have x equals 0 for an asymptote. So we're going to have a vertical asymptote instead. This is our graph of what we say is log base 2 of x. I'm not going to worry about the algebra behind this yet. That's going to come up in a couple days, so I don't care about that. What I would like us to point out is that for our exponential graph, we have a y-intercept at 0, 1. And for our log graph, we have an x-intercept at 1, 0. For our exponential graph, we have no x-intercept. And for our log graph, we have no y-intercept. For our exponential graph, we've got an asymptote of y equals 0. And for our log graph, we've got an asymptote of x equals 0. All of the x and y things are switching so that we can have this way of really graphing these without having to do kind of plugging things into logs, which we're not comfortable with yet. All right, we're asking for 2 times log base 2 of x. The first thing I'm going to do is to make my x and 2 to the x equals y table. Because I'm going to switch things around for the log just to kind of make sense of that. So here I'm going to go from, let's say, negative 2, negative 1, 0, 1, and 2. That becomes 1/4, 1/2, 1, 2, and 4. And those are the points that are on the graph that were given already. We've also got an asymptote at y equals 0. For my log graph, all I'm doing is switching these around. And I've also got 2 times that value that I have to deal with, which I'm not going to do right away. I'm going to hold off for just a second. So my first point that I'm going to see, and I just erased instead of wrote, that's always fun. First point that I'm going to see is going to be 1/4, negative 2. We just switched the x and the y for that. Second point is going to be a half, negative 1. Third point is going to be 1, 0, and then 2, 1, and then 4, 2. My asymptote is supposed to be x equals 0 for this. The last thing I have to do is take this, and because we're multiplying this times 2, I've got to multiply each of these values times 2. So really that'd be negative 4, negative 2, 0, 2, and 4. Okay, Let's graph this thing. I've got x equals 0, so I'm going to draw that asymptote in. I've got the point 1/4, -4. I'm going to try to do my best on that. It's going to be really hard to see. I've got 1/2, -1. That's also going to be really hard for me to see, but I'll do my best. I've got, sorry, it should be -2. I already screwed this up. There we go. I've got 1, 0. Cool. I've got 2, 2. So there's 2, 2. And then we've got 4, 4. So 3, 4. It's going to be up there. My graph is going to look something like this, a slightly steeper log graph because we're multiplying each of those y values by 2. All right. Here we've got a couple of things we need to define. I don't see a base here for this log. I will describe that this is called a common log, and anytime that we see something without a base, it's log base 10 of x plus 4 and then 2. Okay. I'm going to start off the same way. I'm going to make my xy table for y equals 10 to the x. This one's going to be really difficult to see because these numbers get so big so quickly. In fact, I think like if we were to do -2, -1, 0, 1, 2, we'd end up with 1 over 100, 1 over 10, 1, 10, and 100 to try to make some sense of those. Most of those points don't make any sense in terms of trying to show on this graph, so we're kind of stuck with these three. For my log graph, I'm going to make that blue to match. I'm going to call this log base 10 of x. So we've got 1/10 and -1. We've got 1 and 0, and we've got 10 and 1. Now I'm going to look at these transformations. X plus 4 on the inside means that we're going left 4. And then plus 2 on the outside means we're going up 2. So if we're talking about the final things here, I'm going to do these in yellow. My final x and my final y would end up being, okay, 1/10 is 0.1, going left 4, -3.9. -1 going up 2 is going to be +1. 1 going left 4 is going to be -3. 0 going up 2 is going to be 2. 10 going left 4 is going to be 6. And 1 going up 2 is going to be 3. These are the points that we're going to use. We would normally have, sorry, I forgot to do the asymptotes, an asymptote at x equals 0. That's going to go left 4 as well, and my new asymptote would be at x equals -4. Let's draw that first. So 1, 2, 3, 4. Then we've got the point -3.9, 1. That's going to squish like right there. -3, 2. And then we've got 6, 3. 1, 2, 3, 4, 5, 6. 2, 3. We end up with a really, really steep graph that turns really shallow very quickly. All right, we've got one more that's based on the same thing. Here we've got 3 transformations at once. That's going to make this a really interesting graph that we may not even get to show up on here. I'd like to remind us this is log base 10. And if we take a look at the table that we had the same for the last one, for 10 to the x, -1, 0.1, 0, and 1, and then 1 and 10. Nothing else will show up on this graph. Y equals 0 would be the exponential asymptote. So when I go to build my log form of this, just for switching these around, this is log base 10 of x. We'd have 0.1, -1, 1, 0, and 10, 1, with x equals 0 being the asymptote. Now I've got to apply the stuff that's going on here. I see y times 10 out front. I've also got x plus 2, that means left 2, and we've got a down 2 as well. I'm going to do the x stuff first. So in my final table, we're going to have 0.2 going left 2 would be negative 1.9. 1 going left 2 is negative 1. 10 going left 2 is 8. And our asymptote would become x equals negative 2. I'm going to put the asymptote on first. Okay, so now for the y's, we've got to do times 2 and then down 2. So times 10 down 2. So for negative 1, we've got negative 10 down 2 is negative 12. I don't know if that's going to fit on my graph. 0, we've got 0 down 2 is negative 2. And then we're going to have 1 times 10 is 10. Down 2 would be 8. Let's try graphing some of these things. 1, 2, 3, 4. I just lost track. 1, 2, 3, 4, 5, 6, 7, 8. There's 8, 8. Negative 1, negative 2. And then negative 1.9, negative 12 would be somewhere down here. Our graph would look like this. The times 10 out front makes this grow a lot faster at the beginning than the previous one that we had.